Okay, I think we should start. I'm sorry, they're not here. They will arrive. Okay, let's talk about the existing corpora. There are a lot of people working on parliamentary speeches and from around the world. And here I collected all the existing corpora that you can use to analyze parliamentary speech. First of all, just do some introduction on how a corpus is created. And there are some steps needs to be done. The first steps usually are done by the institutions, while the steps forward can be done also by us, by researchers. For example, you need to retrieve the original documents. For Italian Parliament, for example, I don't know where physically these documents are stored, but luckily, for example, Senato and Camera provide directly the PDF files. You need also to scan the documents. Documents can be books, can be a huge piece of paper like rotoli, I don't know how to say roll. And so they can be in different formats and need to be scanned using very expensive tools. Then you get the usually TIFF files or PDF. You can extract the text using OCR. So this is a task that we can do, we all can do. You need to check and correct and clean these OCR scan documents. Okay, you need also to save and structure the corpus. This is not that easy, as we will see. And also we should evaluate how all this process has been done. So if the text is correct, if the metadata information are correct, and other stuff. Retrieving the original document. This is the task I haven't done. You need to understand whether the original documents exist, where are stored. For example, in which format they are paper. There are, for example, handwritten. They are printed. Probably there were queue at the coffee machine, or it was very far from here, the coffee machine. Ah, sorry. Ah, okay. Sorry. We were discussing about how to build a corpus. So we want to build a corpus, for example, for the parliamentary speech of a particular country. Okay, the first step to do is to understand whether this document exists, where are stored, if we can use it, because there may be a license for this data, or they can be owned by a private company or a private person. So you need to understand which license can be used, and also to understand whether they contain also some sensitive information before scanning and publish them. Okay. Then you need to find the correct device. Sometimes the devices are very expensive and are not very common to find. In the next slide, you will see a very nice institution in Italy that perform this kind of tasks. You need to understand which file format to save. Usually TIFF is the best format to save this kind of documents, and the best practice. So when you take a photo of a document, you need to specify, for example, the precision, I don't get the word, the resolution of the document, understand if you want to compress or not. Probably if you use TIFF, you don't want to compress, and if you want to save which kind of images and so on. This is a very good research center in Modena. Is the Unimore. I don't know if you know it. Unimore is the University of Modena and Reggio Emilia, and has a very good laboratory on how to scan ancient texts. I don't know if they perform the digitalization of the Camera and Senato documents. Probably not, because this job was done before they started to at least to advertise they exist. I went them. These are photos I took by myself, and you can have more information here. And if you want to have a look and go to Modena, it's very good to go in and see what they work on. Then you need to extract text using OCR. This is a very bad task. It's very complex. I mean, it's very long and it's very slow, because Tesseract that is the most used software to extract text from documents, use convolutional neural networks, sorry. So it's quite slow, especially if you use it on CPU, but there is not an easy way to use on GPUs. So for me, on FBK machines, it took around 1 month to perform all the digitalization of the Italian parliament. After that, you also need to clean the documents, especially when you take a photo. You need to adjust contrast, adjust brightness, and remove noisy. Some old documents are very, very noisy, so there are spots, there are drops of ink, and so on. And another very, very hard task is to align the text. So you have some documents that have 2 columns, some is 1 column, sometimes there are images, tables inside the documents. The most common tools to extract text from images is Tesseract, is free, is open source, is developed by Google. And other alternatives are Ebifine Reader, is very famous but very expensive. And also you can use Amazon or Azure cloud services that are not very expensive, but if you have 5 million documents, you spend a lot of money. You need to ensure that OCR recognizes your language. I mean, if you scan documents in Italian or French or English, this is not a problem. If you scan documents in Hindi, probably you need to ensure that your software can deal with this kind of text. Then you need to decide which output format. This can be something trivial, but is not, because, for example, if you ask Tesseract to give you, for example, the plain text, it's then easy to parse, it's a text, but you don't know where was the text in the page. If you ask, so you have only the text, but you have also headers, footers, footnotes, image captions, and so on, all together in this textual file. So if you need to study the frequencies of the words, this can be a good option. If you want to understand, for example, if you want to split between speakers, or you want to have complete sentences, this can be a mess. So another option is TSV. TSV gives for each word also the position in the page. So you can have quickly the whole text by taking just the words, or you can build another layer on top of this TSV to understand whether a particular set of words is a caption of an image, or if it's an header, a footer. For example, one of the difficult tasks to clean the Italian Parliament dataset was to remove header and footer, the page numbers, the titles, and or the indexes, for example. At the beginning of the document, there is the indexes with all the people speaking with the number of pages and so on, but you need to remove this kind of information. And there is also a third option, the XML, and this is a very, very interesting option because it gives you also the alternative. So I am the tesseract, I am over here, okay, this for me is an O, but it may be an A because I'm not very sure because it's dirty and so on. So you can have all the probabilities of all the letters in all the words. It's a very big XML file, but if you want to fix some errors, you can have a sort of additional information on which is the most probable word that can replace this surely wrong word, okay? If there is something that is not clear, just stop me and ask, okay? Yes?
Yeah, I have a question. So how do you link the output to the original image? Do you want to keep this? So like, let's say I'm going through the text and I want to go to the actual source image because I think there is some problem. How do you link this to in practice?
In practice, the coordinates of the image,
So
the pixel.
But you say like you have the name of each page is a single file that you can refer to?
Yes, when you use Tesseract, you give to Tesseract a JPEG file. You cannot give to Tesseract a PDF file, so it accepts only images, so you need to perform this task page by page. And for each page, it gives you, for example, the TSV file, and you have the coordinates of the pixel where the word is. And Tesseract gives also the lines, the blocks, and the paragraphs, and also the columns. So the TSV file is probably the best option because you can perform some cleaning easily, while if you get just the text, it's a mess. And in fact, you can also, for example, use some tools, for example, ImageMagick, to draw the blocks on the JPEG file so that you can understand quickly by viewing it where the problem was. Sometimes the blocks are misidentified and you get text that is nonsense, but simply because there is maybe a white spot or something that has been deleted for some reason because the document is very old, and you get two blocks while it was one single block. We have an example in the next slides about this. Okay, the common errors in OCR are misrecognized characters, so a very common is the L with the 1. That in most fonts is the same character. Also segmentation issues, so you may have that the header or the footer are merged into the text. You can use some correction techniques. I tried, when I worked on the Italian parliamentary speech, there was not a large language model usable. So I tried to correction the spelling, but this is not very useful. Okay, you can manual review. This is the best way to correct the OCR output. Otherwise, a new way to correct this is to take the text, give the text, the wrong text, to a large language model and ask if it can fix the errors. And it works well. We will see, I have a Python script for you in which we will use these techniques. Also the manual, if you want to correct manually. Okay, this for example, is a case in which, I don't know why, it misinterpreted the boxes. So for Tesseract, these were 2 columns, and this was very bad. But if you have the coordinates of each word, you can try to fix these cases. These cases happens for very, very old documents. For newer documents, this does not happen usually. And on the top, you can see how dirty can be a document. So it's very bad even for a human to read this text. Imagine for a system, for a technical system. So this is challenges you have when you deal with very, very old or big corporate with very, very old documents. Then you need to save the corpus and structure in some way. Why I tell you that it's a very difficult task? Because once you decide the format, okay, you can change it, but in some way you need to work on this format. And the most common one is the XML-TEI, is a textual initiative, but we have a slide about it. But it's a very, very complex format. Usually the Python pipelines works on JSON, so JSON can be a very good option, but JSON is not, has not something already decided for parliamentary speeches or CSV. You can use the CSV. In CSV, you cannot, for example, add the metadata, so you cannot add the speaker names, the date, the session, and so on. So you need to understand which is the best one. After that, you should evaluate your jobs. There are two kinds of evaluation. The first evaluation is technical evaluation. So I have my OCR output. I want to evaluate how the OCR was good. So I need to transcribe manually some pages and compare these results. Then you can perform an evaluation on the annotation that you add after. So I use Spacey, for example, for add ParlaSpeech tagging, syntax tree, and so on, and I want also to evaluate how good is this secondary annotation. In choosing the best format, just remember this. Just remember that everyone usually decides to invent a new format because all the formats available are not enough for my kind of activity. And for this reason, in general, it's better to choose between formats that are already used. ParlaClarin, that is Parliament, sorry, that is a project, a European project that collects all the parliamentary speech, but the ones you can find in web format. So the ones that is correct, it's saved with XML-TEI. I don't like this format, and there is a slide that explains why. RDF is a very common format to share data with other people. You can query it using SparkQL. I don't know if any of you knows about RDF. Personally, it's the best one for this kind of activity. In fact, the Italian parliamentary dataset is released in RDF format. You can use also JSON or JSON-LD. JSON-LD is something that tries to compare JSON to RDF. JSON is very easy to read, very common, but it's not structured, so it's more difficult to use with other datasets, or you can share in plain text in CSV. The Italian parliamentary dataset is also released in plain text file. So if you want the text, you can just take the text. XML-TEI is designed for a lot of possible text, probably all the possible text. They have a markup for the structure, so you can mark up the headings, the titles, the main body, and so on. You have a support for annotating stuff, so you can add, for example, ParlaSpeech tagging, lemmatization. You can add all the information you want. It has a hierarchical structure both in the document and in the part of the documents. It's really hard to understand. It's really, really hard, and it's really verbose. If you tag one document, it takes megabytes of data. And if you want to study the official documentation, is 2,600 pages. Okay, this is why I haven't chosen this, because I'm very lazy. I don't want to read. Come on, you don't need to read everything, but it's really a verbose format. I personally prefer RDF, in particular because I worked on RDF in the past and it's very easy to integrate. Both Camera and Senato already release all the metadata of the parliamentary speeches in RDF format. So if you want to understand which parliamentary members were present that day, how did they vote for a particular votation and so on, you have all this in the metadata in RDF format. So when I release when we release the parliamentary debates, the Italian parliamentary speeches, we add some triples to the already existing dataset. As you may know, RDF is a triple-based structure, so every atomic information is a triple, a domain, relation, and range. You can link with external knowledge bases. For example, we linked all the parliamentary members to Wikidata, so you can get automatically a bunch of metadata such as where he was born, when he joined the parliament and so on. The challenge is that you need to learn a language if you want to query it, but you can query it. In XML you cannot easily query and, for example, give me all the speeches by this person given on this topic. It's very hard to do it in XML. In RDF you can, if you have the information in the triple store, obviously. Yes?
Can you make an example of how you actually structure in practice? So how is the triple? So is the entire text or?
No. We release the text and then we release the triples, and for each speech and for each member of parliament we put the offsets of the text. So you need to have also, because it was very, very verbose to add the whole text of the whole Italian parliament in RDF. RDF is not made for long text usually, so we only added the offset. And a nice paradigm of RDF is that probably if you want to do something, someone already did it for you. I mean, we wanted to use offsets, and we wanted, okay, is there a way to tell, okay, I want to identify this offset with an identifier and so on? Yes, you already have an ontology. RDF is made by ontologies in general. You already have an ontology that is made to select part of texts. So you don't need to invent anything. Probably what you need has already been invented. Okay, and this is one of the big powers of RDF. Have you worked with RDF? Do you know about it? Okay. You also can use more simple formats like JSON. JSON is very common, it's very human readable. You can have a structure like XML, but it's more readable. You can understand by opening it by a text reader. You can use quickly also in API-based data sharing. So I want to make an API that everyone can use. JSON is a perfect format because all the APIs in the world are use JSON as formats. There is not a standard for parliamentary debates. I mean, you don't have a standard. You need to invent it, and probably if another person invented another format, it's different from yours, and so it's difficult to use all the data together. So how to choose the right format? You need to consider some factors, the complexity, so how rich is the metadata and how complex is also for me to learn this format. What do I want to do with this data? So what are my goals, my challenges, and also what are my skills? So for example, if I didn't study information technology, XML is very complex for me. JSON is easier, or text, or plain text. In general, RDF is better for datasets that should be linked with other datasets. And I think that parliamentary debates are this kind of datasets. XML TAI is a very rich format if you want to add a lot of metadata to your documents. And JSON is the most flexible if you want to analyze stuff on this data. Probably the best option is to release in all the format, but it's really a mess. I mean, who wants to do this? Let's have a look on the existing corpora. There are a lot of existing of works like the ones described. There are some smaller, for example, Dutch Parl, Czech Parl, and CParl, but it's quite famous. For example, CParl is the dataset of the Slovenian parliamentary debates. Slovenia is a very young country, so they don't have a lot of data. They started to collect data in 1990. So it's one of the smallest one, also for Czech Parliament, because also Czech Republic is a very young country. But they have a very, very smart community around it. So they performed a lot of studies on this small amount of data. It's a sort of paradox because, for example, for a Polish parliamentary corpus, there are not a lot of studies around it. The Italian parliamentary corpus was done by me and a student of mine 3 years ago and did not exist at all. Some countries have communities that are more active on this topic. The biggest one is the Hansard. Hansard covers 2 centuries in practice, and it's the biggest one even in terms of tokens. The size is expressed in tokens, except for the US congressional records that is expressed in documents, and it's very hard to investigate. I tried to download it, but it's very hard. It's very big and not very. But the US Congress has a very, very good web interface, the official one, in which you can search for keywords and you can perform some very nice search and analysis without any researchers that download it and build it for you. The Parliament project is one of the biggest projects. It collects, as I said, all the parliamentary speeches that can be found online, so that is already in a correct form, and is quite big. And the nice thing is that you can compare different countries. The project started in 2015, but for some countries that data is older. For example, the Italian ones goes to 1996. The Italian one is the one developed by me and my student. And URLEX is the dataset of the European Parliament. Okay, so I think that the name is wrong because this is of the laws. I need to check. Probably this is. Anyway, it collects all the documents from the European Parliament from 1949 to present. But there is not a community around it. I mean, you can use it and download it, but there is not a smart community who studies and so on. The German parliamentary corpus is quite big. It started in 1867, and it's the one that is most similar to the Italian one because they had the same issues. It's older than the Italian one, and we will discuss in details here. They collect, the author of this dataset collect not only from Germany, but also from Liechtenstein, Austria, Switzerland. I don't know how big can be the Liechtenstein dataset of parliamentary speeches. And the main challenge they have is about the fracture font. Okay, fracture font is hard for me to understand, so I don't know how it was possible that they wrote the parliamentary speeches using this font, but this was a problem. And so they have to deal with a lot of issues linked to the images, to the scanned images, because this font, if it's dirty, the letters overlap each other, so it's very difficult to clean. So they adopt some strategies directly on the images. So they scan the images and they divide into group of good quality and bad quality images. The bad quality images probably was the one written in Fracture. Also because Fracture, the oldest documents was written in Fracture. The recent documents were not written in Fracture. And then they convert the color, okay, they erode and delete the images, they filter to remove noises, and so they adapt a lot of stuff that we didn't need to adopt for the Italian parliamentary documents. They also add metadata information from SPACY, so they added part-to-speech, lemmatization, and so on. And then they also spell checked, but they use spell check just for a quick analysis on how good it can be, because probably they tried to correct using spell checker, but they deal with the same problem we dealt with, and if you use a spell checker, you get worse results than keeping everything like Tesseract gives to you. So don't use a spell checker on OCR. The US congressional records are scraped by Stanford from the US Congress website. The US Congress website contains all the documents for both chambers since 19th century. They passed through OCR, as everyone did. They also collect diagrams. This is very interesting because you can search quickly for a couple of words, for example, climate change. Probably if they will do it now, they also collect some other information like trigrams or collocations, but they did not. It's very big. They also automatically assign the speech to the speaker. This is a very hard task. We tried to do it for the Italian Parliament. We did it for most of the documents, but for older documents it's very, very difficult. It's very, very difficult to be accurate. And we will see it after the ending of the slide presentation. The Polish Parliamentary Corpus, again, they extract text from the PDF using OCR. From 1989 to 1993, they also manually correct all the documents. Before 1989, just OCR. They saved it in TEI format, unfortunately. They also add some automatic annotations. In this corpus, they also add named entities. That is not very common for this kind of dataset. It's very useful to have named entities, but it's not very accurate. So usually they said, okay, this is the dataset. If you want to extract named entities, just do it by yourself. The answer corpus is the biggest one, as we said. It collects all the speeches from the British Parliament. It has 1.6 billion tokens. Again, it's an hybrid process. It's more hybrid than the other one because some documents are written by hand in the beginning of the 19th century, so they had to manually copy this text. Then they apply OCR for the other documents, and the more recent ones are digital. They have a very, very good interface, and we will see it. They have a quick interface. You can perform quick and collocation and word frequencies directly on their website. This is a very, very good stuff, and this is how I collect the charts I put on the slides. The fact that Italy was cited in 1860 is because they have a very, very good web interface. I'm very jealous because I wanted to do it also for Italian one, but it took a lot of time. I will do it probably in the future, in my next life. Yes, if I move a lot, I don't. Okay. Okay, this is Ipsa Corpus. It's developed by me and a student some years ago. It's the second biggest and the second oldest. I'm the second. Silver medal. It has 1.2 billion tokens. We tried to assign automatically the speaker, and I will show you how precise it is. And this was a very, very difficult task. Probably now that we can use LLMs, it can be easier, but LLMs has a very, very bad property that they are expensive if you need to use a lot of queries, and they are slow. They are really, really slow. You cannot ask for an LLM for 5 million pages. It takes forever. With respect to the GERPAR corpus, as you can see, we avoid to do a lot of tasks. We didn't use Spacy to add the metadata information, and we didn't perform anything on the images because the Italian government, the Italian parliament already gives the documents in a very good shape. So you don't need to adjust brightness or contrast. They are very, very beautiful documents. We also manually wrote a test set made by 58 pages, randomly extracted in the whole set of pages to check whether the OCR was good and the extraction of the parliamentary speeches was good also to the speaker. And so we take this document and we transcribe manually by copying it. It's a very boring job, but you need to do it. We tried to spell check it using various strategies, but we couldn't reach the original OCR. So when you apply the spell checker, you add errors more than the ones you remove. We also tried something that we thought it was smart, but it was not. When you have a spell checker, you can train it on your documents. So we take documents from the same period we want to check. So for example, we want to check the 8th legislature of the Reign of the Kingdom. We take documents between the 6th and the 10th. We collect all the word frequency. We cut below 10, I guess, and we keep all the other words. So probably they are real words and they are correct words. And we check the 8th kingdom with these words. If they find that a word is not included, just find the most similar one. We guess that it's wrong. But okay, if we apply SimSpell from scratch, this is character error rates and word error rates. There was a slide, but oh, sorry, it was the next one. Okay, word error rates mean how many words I need to subtract, replace is. It was a synonym of replace starting with D, but I don't remember. Anyway, substitute, delete, insert, sorry. Anyway, you need to sum how many words you need to remove, to add, or to replace, divided by the number of words. The character error rate is the same, but with characters. How many characters I need to add, replace, or delete. And you can see that the lower the better. So if we apply SimSpell from scratch, we get really worse results. If we apply this windowed strategy, we do slightly better. If we apply it lowercase, we reach almost the original data, but anyway, it's better to leave it as Tesseract gives to us. This is an evaluation of this matrix during the time. You can see, especially for word error rates, that when the documents are more recent, you get obviously best results. This is quite obvious. This is a very nice graph that shows you the thickness of the bar means how long was the legislature, and the height is how many words per day were written into the documents. There are some nice things. Okay, after the Second World War, they spoke more, probably because the Senate was elective, while before Second World War, the Senate was nominated by the king. So they discussed less than the other representative. It's very interesting how during fascism, no one was saying anything at all. And again, you can see a change after Second World War. And also there is a universal suffrage and so on. So there were women in the parliament, so there was much discussion on much topics. We also evaluate the speaker identification. It's not an easy task because sometimes it's, for example, senatore primerano or presidente, or sometimes there is only the surname, Pellegrini. Sometimes there is the surname, all uppercase, and if there are ambiguities, they put also the name. So Mirabelli, Roberto, because probably for this legislature there were more than one Mirabelli, and so they also put the name. So it's very hard to get. We downloaded all the parliamentary members since 1848 for each legislature, so we try to match the names just for this legislature. But it's hard because sometimes you have members of the government who speak in the parliament, and not all members of the government are in the parliament. So it's quite tricky. And sometimes, especially to understand the president, you have that sometimes the presidency change during the talk, and when it changes, you have now it changed. The new president is Venanzi, so when you see Presidente, you need to replace with Venanzi. During the speech about the Mondine, the women collecting rice, they changed 5 presidencies. Because, they probably would need to go to the toilet or to sleep. 3 days. Okay, this is evaluation of the speaker identification. Again, when the document is very recent, the results are the reason why it's a very bad line is because we have only 58 documents, so it's not a huge number, but you can see that for older documents you have problems in identifying. This is precision recall F1. Do every one of you knows which represents precision and recall? You can see that the green line, the recall, is very low, it's 80%, but it's quite low for older documents because the recall represents the coverage. So a lot of names cannot be identified, while precision means that you identify the name, but you classify the wrong politician. Okay? So precision usually very high because if you identify that there is a speaker, usually you don't misunderstand which speaker is, but the recall may be lower because you miss at all a speaker, okay? This is a map showing which corpora are included in Parliament. Parliament is the one biggest of all Europe. It includes also some countries that are not in European Union, like United Kingdom, Iceland, or Turkey, and Ukraine, for example. And I don't know why Germany is not included, since there is a data set called GerParCorp that is very, very big. I don't know why. Italy is present, but only between 2015 and 2022, so only the documents you can find on the websites. And it's very useful if you want to understand differences between different countries, between the various countries. Okay, the second part of the talk is ended, so we can have another 10 minutes break, and then we will see some examples. We will see also all the websites involved in the parliamentary speeches.